Hello everyone, welcome back. Let's do example 6. X is a continuous random variable with probability density function. We are of what? Of gx. So now they use g for the function. We have two gx, which is first one is hx squared, and this is the condition. And we have another function gx as well, but it is equal to 0. But otherwise, what does it mean by otherwise? So let me help you. So we need to draw the number line first to understand the question. So this is the condition where negative 2 and 2 is having a dense circle. Okay, so these are the function for hx squared, while the function for gx is equals to 0 is at this part. Oops. So otherwise mean either to the left or to the right. Okay, I think you have known how to solve this part, right? So how to draw the number line, I mean. So otherwise means any part other than the middle part here, okay? Because hx squared gx is equals to hx squared is already said in this part only, in this region only. So we must understand that this is how important you understand the question first before solving it. So the first part say find the value of h. How to do that? Okay. So in order to find the value of h, we need a definition. We know the definition for probability density function. The total probability is always equals to 1, whatever limit given to us. This is the limit, right? Sorry, this is the only limit given to us, which is from 1 to which is from negative 2 until 2. So it's very easy. All you gotta do is that you put the definition. The definition, which is the integral of the gx, okay, where the limit is from negative 2 until 2 is equals to 1. The total probability will give us equals to 1, right? But before I put the 1 there, maybe it will be helpful if I put the function gx, which is hx squared. Close it down with dx, and then I put my 1. Total probability is equals to 1. So basically this, when you write this thing, you will get the first mark, okay? First mark, because you understand the definition of PDF of the continuous random variable, where even though you nak letak kosong ni, pun sekali di dalam probability pun boleh juga. But in the end, this is just plus 0 will give you the same answer anyway. The only function there is still hx squared sahaja di dalam ini, right? So yeah, we can start to find our h right now. Let's find the h. All we gotta do is that we integrate the hx squared. How do we do that? So hx squared integrated, we will get hx cubed over 3. In a big bracket, put the limit together, which is negative 2 until 2, we will get, and then equal it to 1. And then don't forget to solve it by insert the limit 2 and negative 2. And so we will finally got our h value, which is 3 over 16. So I don't really have to explain these things because you already know how to integrate any type of function, right? So now we already solved the first question A. Question B, calculate the px less than 1. Probability x less than 1. Where is 1? Have a guess. Where is 1? 1 is over here. No, this is 0. So here it will be 1. So The region where x, probability of x less than 1 is around here. X less than 1 is around here only, okay? So we will take the limit of -2 until 1 sahaja. Okay, careful there. We will only take the limit from -2 until 1. Okay, at the back here, you forget about it. So that's it. You just need to write down the integration. You can also write down the function. So the function right now here is 3 over 16 x squared. Am I right? Sebab apa 3 over 16? Sebab kita sudah pun cari the value of h. We already got the value of h, so we can just sub in the h there. We gotta use the h lah to solve the next question here. So use the 3 out of 16 there, put in the function. This is h, right? So h x squared. So this is the function, the real function that we want to use. But then put the limit of -2 until 1 sahaja. Sebab apa? Sebab tadi saya kata the region that we want to find is from the limit of -2 until 1 sahaja. So that's why -2 until 1 only. Okay, even though the probability got no equal there, it's okay, no worries. The upper limit is still 1. Okay, the upper limit is still 1. Put it 1 there. Don't change it. Okay, whatever here, just use it. And then we are ready to solve this part, which is 3 out of 16. Put it outside, and then here goes x cubed over 3. And the limit is -2 until 1. And then I can simplify them by cutting this number 3, and then I solve it simply. 1 over 16 times with something cubed minus something cubed. Okay, that something will be 1 and -2 inside here. And then the answer is just, what is this? 1 minus 8. No, 1 plus 8 is 9, so 9 over 16. There we go. That's our answer for probability of x less than 1. Now, let's solve question C, which is finding the probability of a modulus x less than 3 over 2. So whenever you see a modulus, you know what to do already. It is just probability of x in between two numbers, right? In between two numbers, which is one of it is -3 over 2. Another one is +3 over 2. Yes, you do know how to write this. We call this in between. In between, it always put less than like that. Okay, don't ever change it. So this seems very familiar, isn't it? This seems very, very familiar at my notes here. Go down again here. This is the characteristics of PDF, probability density function, where whenever you see P, okay, finding the probability of X in between the limit A and B, you can write down in terms of integration, okay? Remember, PDF, density function, is always involving integration. So you will never run away from integration. You must put integral from a lower limit to the upper limit, A and B here. And then you integrate with the function with respect to x, okay? For now, it always x lah. And so, it seems very familiar. This is the characteristics of PDF. And so, we know how to write them in integration, which is the integration of 3 over 16 x squared of the function, right? And then close it with dx. And then don't forget to put your limit -3 over 2 until +3 over 2. Okay? So I think you gotta still double check. How do you know this is the correct function that you must choose? So let's recall this. This is -1.5. You know that? This is positive 1.5. So you look back at your apa ni? Real number line here. So 1.5 is around here, negative 1.5 around here, 1.5 is also around here. So if you shade the region, the function that you need to use is still h x squared, which means the 3 over 16 x squared. Therefore, it is in this region where the function is being used. Therefore, I think it is always important to double check your limit, your lower limit or the upper limit here, whether it's inside of this region or not. Okay, if this is inside of the region, it means you can use the function. So be careful. This is easy because there is only one function. You must always look at whether it satisfies the condition or not. Okay, always check it satisfies the condition, okay, to use this particular function. And now our job is to what? To integrate it, right? So sorry, I gotta make this a bit smaller because I don't have space there. Okay, oops, please make it work. Okay, so now we need to integrate it. So I put 3 over 16 outside, so I'll be left with x cubed over 3. And then we must always put the limit, negative 3 out of 2 until 3 out of 2. So don't forget, we can also cut the number 3 to simplify it. And then I got this. Then I can now sub in my x for this 2 value of the limit. And then I got my answer, which is 27 over 64 for the probability of P, probability of x less than, modulus x less than 3 out of 2. So this is basically the definition as well. Okay, this, even though I call this characteristic, okay, but then this is also the definition. Please get used to the word say here, definition of the PDF. All right. So then next question is asking from you, m means a number, a constant. Okay, so next question here is asking you probability of modulus x as well, less than m, but then it is equal, the probability is given, which is half, less than, half means 0.5 lah. And so how to find the m? Same technique as the question C there, where x is in between negative m and positive m, close bracket, and then equal to 0.5, right? And then you can also, and then you know how to write this definition already. Oh God, sorry. You know how to write this probability in terms of integration, where integral from negative m to m, where the function is 3 over 16 x squared, again, close down with dx here, and put the given equals to 0.5. 0.5 is a half. Half means the middle. Middle means half of this total probability. Okay, where we know half is where the middle function is being used, That's why we still use hx squared as our function. Okay, the function must be always correct lah. So the function is correct when you choose 3 over 16 3 over 16 x squared. Why is it correct? Because it's in the middle data. In the middle data is where this function being used, hx squared, or I should say 3 over 16 x squared. That's why I choose that. And then in order to find the m, this is where the definition being used, that. So please get used to the definition, because when you are used to it, you will have no problem in understanding that probability is equals to integration. Okay, and so I just used the technique of integration and I finally found my value of m, which is 1.587. Done. Right, let's do this example 7. X is a continuous random variable that has the following probability density function. So all of this is still probability density function. Find the mode of X for these two questions here, but I will do the first part only. So basically, there is a tips here. In order to find the mode, we must be good in sketching the graph. This is the only way to be finding the mode, you know that? So before we find the mode for this particular question, what I did here is I need to sketch the graph. Yes, I am going to sketch the graph, but before I sketch the graph, I will change this quadratic equation. Sorry guys, this is actually quadratic equation. I will change this quadratic equation into a different form, which I need to use a completing the square method. Okay, so I use the completing the square method here to show you that I can find the maximum point. Okay, so basically this is fx, okay? So I can get my maximum point from this form, you know that? This is quadratic form, but it has been changed into a different form. Okay, this is a quadratic, yes, I know it, but I change it so that I can see a very clear maximum point there. Okay, how do I know it's a maximum? Because the negative sign here indicate a quadratic yang masam. So quadratic yang masam bermaksud kita ada maximum point, right? We know this already. So basically, our maximum point is 4 and 3/4. So this is my graph where my graph said I need to start from the x is in between 3 to 5, you know that? So my condition must be applied here. The condition is given from the question, yeah, from this part. We must follow it. The graph must be satisfying the conditions as well. So make sure you draw only this part, not everything. If you draw everything, it means from negative infinity to infinity, right? But no, the condition is from 3 to 5. So the graph is like that. And so from here, we know the maximum point. So the maximum point here, the probability is 3/4, but we do not want the probability. We actually want the value of x, because this value of x will give you the mode. Therefore, our mode is x equals to 4. So now I want you to try it by yourself for the second question here. The answer for the mode is 2. All I want to say is that don't forget to apply this condition. Okay, apply this condition very, very carefully. You must sketch according to this condition and then you can get your answer, the mode. If you do not apply this very, very carefully, you will never find your answer. Good luck.